Hey guys, you guys asked me 6 questions via email or via messaging, and so I wanted to answer those 6 questions from your homework from the sections 5.1 and 5.2. So let's take a look at these 6, and when we're finished, if you guys have any other questions, make sure to message me. I'll try to get them in as best I can. And the tests were uploaded, so if you haven't taken a look at those, make sure you do. If you wish to make text corrections, you may always do so. I tried to submit which points you missed on which problems, so you can, if you wish, redo those problems and get the return points for half credit for any ones you do so with. So let's take a look at section 5.1 first. In section 5.1, we had 4 questions. Number 27 was the first one. And so let's take a look at 27. So 27, 31, and 33 are the first 3 questions, and they're all very similar. So I'm going to do 27 and 31 for sure. And then if we need to, I can do 33 a little faster to showcase kind of the different ways. Some things to point out here. The question states, for the following exercises, use the vertex, hk, and a point on the graph, xy, to find the general form of the equation of the quadratic function. So let's take a look at 27. The problem states we have hk equal to -2, -1. And we have a point, xy, equal to -4, 3. Now, first thing I want to point out here, we are going to use h and k directly in vertex form. We're going to use the point afterwards. So let's talk about vertex form. Vertex form is y equals a x minus h squared plus k. In fact, for a lot of these problems, since they're all going to be very similar, I'm going to go ahead and copy that formula up here because I know I'm going to use it a lot. Okay. So I actually already know what h and k are, so I'm going to do a direct substitution. Everywhere there's an h, I'm going to replace with -2. Since I will end up with a double negative, because h is -2, I get +2. And then k, so plus a negative number is just a sum of subtraction. So I get this equation, which has a in it, which is a problem. And this is the point. Once we're here, I'm going to go ahead and make sure to save this equation. I want to get to here because this is a big point, because this equation is really close to the end, but I can't stop here. I need to figure out what a is. So the next step is I'm going to solve for a. I'm going to do so by plugging in x and y. So I'm going to solve for a by plugging in x and y. What that's going to do is it's going to give me this exact same equation, but everywhere there's an x, I'm going to replace with the x value. Everywhere there's a y, I'm going to replace with the y value. Do this after you've got the equation, not before. Otherwise, you'll end up with a jumbled mess, and it's really hard to do. So now that I'm here, everywhere there used to be a y, I'm going to replace with 3. Everywhere there used to be an x, I'm going to replace with -4. And so let's start solving this thing. So 3 is just a 3. Let's see. -4 plus 2 is -2. Squared minus 1. -2 squared is +4. So we get 3 equals 4a minus 1. And then I could add 1 to both sides, getting 4 equals 4a. And then divide with by 4, I end up with 1 equals a, or a equals 1. That's pretty good so far. Now I'm going to take that saved equation. I'm going to come back here, and I'm going to substitute for a. Now that I know what a is, I can go ahead and plug it in. So I would have y equals a, which is a 1, times x plus 2 squared minus 1. Now, this is considered vertex form. So if the question just said to get an equation, vertex form is acceptable. However, the question specifically states, and this is where reading your directions is really important, it says to find the general form of the equation. The general form is when this equation is actually FOILed out. So now I'm going to take the time to do that. So let's do so. foil this thing out. Now multiplying by 1 doesn't do anything, so the 1's going to kind of disappear. Remember, anything squared is just that thing times itself. Remember, from pre-algebra and algebra 1, multiplication has to come before subtraction. So I'm going to multiply these two together using FOIL. So I'm going to do x times x, x times 2, 2 times x, 2 times 2. Let's do it one piece at a time. X times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. And don't forget, we still have the minus 1 over here. And then the last step is going to be, we're going to simplify this thing. Y equals x squared. There's no other x squareds, so it's going to stay by itself. We have a 2x and another 2x for a total of 4 x's. And then 4 minus 1 is 3. This is the general form. So it is the correct answer. And you can check it with the back of the book. It should be exactly right. So notice how we did these steps. Step 1, we used the vertex form and plugged into it. Step 2 was we then plugged in x and y and solved for a. Step 3 was we went ahead and substituted back in and got this new equation in vertex form. And because it's a general equation, step 4, the final step, was we had to FOIL it out and simplify. And so 27, 31, and 33 are all very similar. So let's look now at 31. Now that I've got 27 done, I can kind of use it as a little framework. So I'm going to follow the same basic steps and try to find the same solution. So 31, it states we have h and k equal to, let's see, 3, 2. We have xy equal to 10, 1. Okay, let me get it on screen for you. Kapow. All right. So, using 27 as a guide, step 1, we're going to use the vertex form, plugging in h and k only. So, here's my vertex form. I'm going to do y equals a x minus my h value is 3 squared, plus my k value is 2. Doing good so far. Make sure I save this thing, because I'm going to need it. Okay, next step, I'm going to plug in x and y. So everywhere there is an x, I'm going to plug in 10. Everywhere there is a y, I'm going to plug in 1. Make sure to, as always, save this spot. I want to come back to that equation later. So everywhere there's a y, I'm going to put a 1. Everywhere there's an x, I'm going to put a 10. Okay. This is going to look like a fun one because I don't think this is going to be as nice as 27 was. Okay. So everywhere there is an x, I put in 10. Yep, looking good. Okay, so now I'm going to start solving this thing. So 1 equals a 10 minus 3 is 7, and 7 squared is 49. Plus 2. Remember, I have to move the 2 over first, so I'm going to do that. I get negative 1 equals 49a. Then divide both sides, 49a. Then divide both sides by 49. I get negative 1 over 49 equals a. That's pretty good. So now we come back to that old equation, and we substitute in a. Y equals negative 1 over 49 times x minus 3 squared plus 2. Okay, this is again the vertex form. If it just says to find the equation, we're done. But it specifically states to find the general form. So I'm going to FOIL this thing out and simplify. So let's FOIL. Just like before, I'm going to choose to rewrite this x minus 3 squared as negative 1 over 49 times x minus 3 times x minus 3 plus 2. Now I'm going to FOIL these two out. I'm going to take x times x x times negative 3, negative 3 times x, negative 3 times negative 3. And don't forget this negative 49 is going to chill out front for a little bit until we're finished. So y equals negative 1 over 49 times this thing. Well, x times x is x squared. Negative 3 times x is negative 3x. 3 times negative x would be negative 3x. And negative 3 times negative 3 is positive 9. Looking good. Plus 2. Okay. Now I can simplify in here. Negative 3 and negative 3 makes x squared minus 6x plus 9. And now I'm going to multiply and distribute this negative 1 over 49. So I take negative 1 over 49 times x squared, or negative 1 over 49 x squared. Negative to the negative would make this positive. 6 times 1 over 49 would be 6 over 49 x. And 9 times negative 1 over 49 would make it negative. 9 times 1 over 49 would be 9 over 49. Plus 2. Last step, I need to add these two together. This was the fun part. So 2 is actually 98 over 49. Takes a little practice to get those. So make sure if you need assistance, you can use a calculator to help you out. So y equals. Okay. Negative 1 over 49 x squared plus 6 over 49 x. Okay, negative 9 over 49 and positive 98 over 49 would make this positive 89 over 49. I don't think that reduces, so I'm going to stop right there. So we have negative 1 over 49 x squared plus 6 over 49 x plus 89 over 49, and that's our general form. So again, notice how 27 and 31 had the exact same parts. You could probably shorthand a lot of these steps by doing some mental math, right? These steps in here are pretty straightforward to do in your head if you want to, but I like to do them on paper to make sure you don't make any mistakes. Same with the foiling, like there's some pieces you can shortcut if you wanted to. But this is if you show all of your work, this is what it looks like. Fun times, right? Taking up a whole page for 2 problems. Okay. Let's take a look at 33, and then we'll do 43 afterwards. So, just like before, on 33, 31, and 29 are all very similar. 27 are all very similar. Let's look at 33. It says we have h, k equal to 1, 0, and xy equal to 0, 1. Okay. Ready? I'm going to see if I still got this. I'm going to predict that the equation for this problem is x squared minus 2x plus 1. Let's see how good I am. All right. Step 1. We're going to plug in h and k into the vertex form. I like to do this kind of stuff to remind me of what my steps are supposed to be. So here we go. So my vertex form, I can pull out my other paper to get that back. There it is. So everywhere there is an h, I'm going to be plugging in 1. Everywhere there's a k, I'm going to be plugging in 0. So y equals a x minus h squared plus k. Okay. Now at this point, I'm actually going to do some simplifying. You can always have the option to simplify whenever you want, but sometimes the options are better than others. Like in this example, adding 0 doesn't do anything, so I can actually just kind of drop it from the problem. And so that's going to save a lot of effort later on, I hope. Okay, ready? So now, step 2, I'm now going to take x and y, and I'm going to plug in. So everywhere there was an x, I need to plug in 0, so a 0 minus 1 squared. Everywhere there is a y, I plug in 1. And then I start simplifying. So next step, 1 equals, okay, 0 minus 1 is negative 1 squared. Negative 1 squared is positive 1. And remember, 1 times anything isn't going to change anything. So this tells me a equals 1. Now that I've got that piece, I'm going to plug a back in. So everywhere there used to be an a, I can now put a 1. So I'm going to take this top equation. Y equals 1 times x minus 1 squared. Notice I always go back to the original. Notice I don't need the plus 0 because adding 0 doesn't do anything. Now 1 times anything doesn't do anything either, so it's actually this equation. Y equals x minus 1 squared. Now, if again, it just said to find the equation, this is the equation in vertex form, and is acceptable if it just asks for an equation. However, if it asks specifically for the general form, I'm now going to do step 4, which is to FOIL this thing out and simplify. So we rewrite x minus 1 squared is x minus 1 times x minus 1. And then just FOIL through x times x times negative 1, negative 1 times x, negative 1 times negative 1. X times x is x squared. Negative 1 times x is negative x. X times negative 1 is negative x. Negative 1 times negative 1 would be positive 1. All right, then we combine like terms, and we are done. X squared is just x squared. Negative x and negative x makes negative 2x. Plus 1 is plus 1. Boom. Hey, got skills still. All right, there we go. Just number 33. Again, 27, 29, 31, and 33, they're all very, very similar. Use this as a general form to solve the remaining one, which I think we only skipped 29, so this would be a good one to use for that. Notice that there's some things you can do along the way to help yourself out. Like here, noticing that plus 0 is not going to do anything. Just go ahead and make that simpler. If you don't notice that, then you're going to have a 0 the entire way through, but it's not going to change your answer. Because eventually you're going to take that 0 and add it to 1 and down here, right? Because you wouldn't add until the very end. And then 1 plus 0 is just 1, so that doesn't actually make anything easier. So there you have it. All right. Now we got our last one from this section, which is number 43. Okay. I'm going to scroll down some. All right. So 43 is very, very, very similar to the 33. It's just instead of giving me HK and XY, they'd give me the picture. So how do I do it? Well, I'm going to make it my first step to find these two things. Now remember, HK is the vertex. The vertex in this case is, according to my graph, we're on 43, so here's 43. If I look at 43, my vertex is right here. Remember, the vertex is defined as either the minimum or the maximum, and so I can look at my picture and see, that's clearly the farthest up point, and that is at the point -1, 2. Make sure you put it in the correct order, x first, y second, otherwise plugging it in later will be very difficult. And now, for xy, I can choose any point. Now, I would strongly suggest using a point that you think is easy to find so that you don't make life more difficult. Like, I wouldn't want to sit here and try to be like, this is clearly, so clearly, 1, 8. Like you could try to guess that, but why do that when I could just choose like 0, -1 at this point right here? Much easier to work with. So much easier. In this case, for this example, there's usually a couple that are good. So this is one is here that's good. There's also one over here that's good, which would be at -2, -1. And all the other points look to be kind of in the middle here, and so they're not specifically ones that I would like. If I look at one like 44 real quick, just to kind of re-illustrate that point, the vertex is usually pretty easy, and there's usually at least 2 points that are also easy. So if you look at this graph, like up here, right there, how I got 7, 7, that's a great point. Or on the other side, -1, 7. Notice how they have similar values. That's because of the fact that they're reflexive. And so this symmetry is real helpful. So there's 43. Now that I've got my points and my vertex, I'm going to treat it just like 33. So let's go through the process real quick. This time I'm going to go a little faster. So I'm going to start off step 1. I'm going to plug into vertex form. Y equals a parentheses x minus, so that'll be double negatives, so plus squared plus 2. And then I'm going to plug in step 2. Everywhere there's an x, I'm going to plug in 0. Everywhere there's a y, I'm going to plug in negative 1. So negative 1 equals a 0 plus 1 squared plus 2. And from there, I would subtract 2 over, simplify that, I end up with negative 1 equals a plus 2. 0 plus 1 is 1. 1 squared is 1. A times 1 is a. Subtract the 2 over, I end up with a equals negative 3. So there's a. Now I plug it back in. Y equals, so this is step 3. Y equals negative 3 x plus 1 squared plus 2. And then, last step, I want to make sure this is in general form. Wait, I'll double check my instructions. Oh, look at this. It just says write the equation. So I can actually stop right here. If, however, you went ahead to take the time to actually get to the other version, the general form, it might look a little different. And so I'm going to go ahead and show that too. But note, for this problem, this is an acceptable answer. Can't stress that enough. Because it specifically states just write the equation. It doesn't say write it in general form or write it in vertex form. It doesn't say anything about that. It just says write the equation. So I know that's as far as I need to go. Okay, so if you went ahead and gone farther, let me go ahead and show what that would look like. Y equals, so I'd have to FOIL that piece out, multiply by negative 3, and then add 2. I'm going to shortcut a lot of that. I end up with negative 3x squared minus 6x minus 1. If you FOILed it out, that's what you would get. And so there we have it. This top equation, again, is 100% acceptable. Unlike over here, where getting that equation was good, but not far enough because it specifically wanted it in the other form. So make sure you're always reading your instructions so you know when you're allowed to stop. And so there's our solution for number 43. This ends the questions that we asked about 5.1. At this time, I'm going to go ahead and do the questions from 5.2 now. So, I'm going to go to section 5.2. All right, on section 5.2, we had 2 questions. They were 27 and 29. So let's take a look at those. Let's get out of here. Cheating. Okay. Here we go. 27 and 29. For the following exercises, find the intercepts of the function. Okay. So, it says to find the intercepts. So let's interpret this. If we look at this word, you notice how it's pluralized? That's because there's 2 versions. There's the y-intercepts, which are the easy ones in most cases, and the x-intercepts, which are the harder ones. And I will do both in this problem as you should. So on 27, let's take a look at what to do to get a y-intercept. To do a y-intercept, we take f of x and let it equal 0, and then solve. No, that's... Oh my gosh, I'm silly. Silly Douglas. Silly Douglas. Don't be silly, Douglas. You do x equals 0. I got these backwards. Oh. I apologize. Doing lots of yard work has really stressed me out. Alright. So, these are 2 different versions of the same problem. One where I plug in x equals 0 and see what happens. One where I plug in y equals 0 and see what happens. And they give me 2 different answers. So let's look at the first one. So, everywhere there's an x, I need to replace it with 0. So, f of x is equal to 0 to the 4th power minus 16. Okay, 0 to the 4th power is just 0. Minus 16 is negative 16. So if it asks where the intercept is at these two values. So we have 0, comma, negative 16. There is my y-intercept. So notice the x value is 0. The f of x, or y as we typically call it, is negative 16. So there's my first answer. Now let's look at my second answer. So it says take f of x and let that part equal 0. Well, what's that look like? Well, if f of x equals 0, that means the left-hand side equals 0. Okay, how can we solve this? Well, I'm actually going to solve it by the direct method. I'm going to add 16 to both sides. When I do, I get 16 equals x to the fourth. And now, I'm going to take a fourth root on both sides. So, on the right-hand side, we're going to end up with x by itself. On the left-hand side, even roots always generate two answers. So if I grab a calculator and do the 14th root of 16, I would get 2. But because it is an even root, I get two versions, a positive and a negative. This is really key here. It's one of the properties of even roots. So if it's a root of 4, if it's a root of 6, if it's a root of 8, if it's a root of 12, of 10, of any even number here, I'm going to always get two solutions, a positive and a negative. So the question asks where the intercepts are. Well, the x value, there are two different x values. That means they have 2 points. One with a value of 2, one with a value of negative 2. But in both cases, the y value is 0. So the question asks, what are my intercepts? Well, my y-intercept is at 0, negative 16. My x-intercepts are at 2, 0 and negative 2, 0. And so there's my answer. And that's how you solve 27. Notice to find the intercepts, we basically split this problem into two parts. One piece where we have x equals 0 and then we solve. One piece where we have f of x, or as we typically call it, y, and set it equal and solve. So there's 27. Let's talk now about 29. 29 is going to be a very similar problem. It's in the same section. But unlike the last problem, it's going to have a little twist to it. In that, we're going to have to use a theorem to get to the solution. So 29. It states we have f of x is equal to x times x squared minus 2x minus 8. Okay, so part 1. Oops, sorry. To find the y-intercept, all I do is I let x equal 0 and then see what happens. Okay. So if I let x equal 0, what that means is everywhere there used to be an x, I'm going to replace with 0. So 0 times 0 squared minus 2 times 0 minus 8. Here's the thing. Whatever's inside, I don't really care about because 0 times anything is 0. So the question asks, where's the y-intercept? It is at the point 0 for x and 0 for f of x. So we have the answer 0, 0. One part down. Notice how I use the x value and the f of x value as my point. Next part, the x-intercept. In almost all cases, the x-intercept is harder. So again, note the process we did last time was we did f of x equals 0 and then did whatever steps were necessary to solve. Well, the steps on 29 are going to be different with the exception that we are going to let f of x equals 0. That's going to be constant because that's how we find the x-intercept. We want f of x equal to 0. We're going to let f of x be 0. We're going to plug that in. We are then going to solve by any means necessary. So let's look at 29. What we're going to do is f of x equals 0. So everywhere there used to be f of x, I'm going to replace with 0. Now, as we discussed in our video, one of the best ways you can do a problem like this is if it's in factored form. The reason we like factored form so much is because we can use the fundamental theorem of algebra. We can use the fundamental theorem of algebra in order to split it into multiple problems. Now, this is partially factored. We have x as one term, and we have this kind of nasty thing here as the second piece. This second piece actually factors farther. So I'm going to make my first step. I'm going to factor this some more. So I'm going to have 0 equals x. Now I'm going to see, are there two components that when multiplied will get me back to here. I'm going to do this by using the AC method. So what do I have? They need to multiply to -8. They need to add to -2. Let's see, numbers that multiply to -8. We have 1 and -8. We have -1 and +8. We have 2 and -4. We have -2 and +4. And that's the list. This one does it. So my two answers are 2 and -4. Since we have a is 1, we just take those two answers, x plus 2 and x minus 4, and plug them in. Okay, that's factored form. If you're not used to doing it that way, there's other ways you can do this exact same step. I use the box method, so the x method. You could also use the old-fashioned AC form, which is how I learned it. Any method works. Sorry. But you should factor it. It makes the problem easier, because now that I'm here, I can use the fundamental theorem of algebra, which allows me to take this one problem and split it into 3. I take the first piece, x, and let it equal 0. I take the second piece, x plus 2, and let it equal 0. I take the third piece, x minus 4, and let it equal 0. And I do these 3 problems separately to see what happens. The first one, nothing. So I just get 0, which means one of my answer is going to be x equals 0, and the y value is 0. Again, that comes from here and that point. Over here, I can subtract 2 from both sides and get x equals -2. This tells me that my next point is going to be when x equals -2, and the y value is, of course, 0. And then my third one, I can add 4 to both sides. So this one tells me that my last point is going to be when x equals 4, and my y value is, of course, 0. So there are my 2 answers. Now notice there's a duplicate, and so I'm probably not going to include it twice because that's just kind of silly. And so really these bottom 3 answers are probably all that you need. Notice that to do this problem, first step was I let the y-intercept, so I could set x equals 0, the easier step every time. For the second one, here I was able to do it directly by using just rules of algebra. Here I had to use something from Algebra 1, factoring. And so I factored it and then used the fundamental theorem of algebra to split it apart. But that's it. So that's the big thing you got to know when it comes to these kinds of problems. You have to be able to take these steps and be confident enough to look at a problem and be like, okay, yes, it looks different, but it's the same process. You let x equal 0 and solve. You let f of x equals 0 and solve. You know, they don't really change. They just may look a little different. And that's not a big deal. So there were the 6 questions you guys asked me about. They were number 27, 31, 33, and 43 from section 5.1. And from section 5.2, 27 and 29. I didn't receive any other questions, but that's okay. If you do end up having other questions, just let me know, and I will try to get those posted as well. Otherwise, enjoy your weekend. Make sure your homework gets turned in, and I will see you guys next week.